Okay, let's try this again. So I had previously already recorded this video. Unfortunately, I found out only after checking through it once that there was no audio of me explaining the question. So I'll just go back through it real quickly to explain how I get to the solution right here. So to start off with, let's find the equation of the plane passing through point 1, negative 1, 1, and contains the line of intersection of the planes x plus y minus z equals 2 and 2x minus y plus 3z equals 1. So to start off, the information that we're going to extrapolate from this question is the point that's given to us, so 1, negative 1, and we're going to say that's point P, and we're going to take the two planes that are given to us, or the equations of those planes. So we're going to take x plus y minus z equals 2, and take the vector coordinates of that, which is 1, negative 1, or 1, 1, and negative 1, and that's going to be our normal vector 1. And our second equation, which is 2x minus y plus 3z is equal to 1, and our vector coordinates should be 2, negative 1, and 3, and that'll be our vector coordinates for our normal vector 2. So our first step is going to be to find the point of intersection. So we're going to take our given equations to us, and we're going to have x plus y equals 2 and 2x minus y equals 1. So we're going to set z equal to 0, and through using a system of equations, we should find that x is equal to 1 and y is equal to 1. And from that, we're going to get our new point right here, which is 1, 1, and 0. And we're just going to call this point Q. Now, point Q is going to, we're going to use for our constants in the equation of a plane right here, which is a times x minus x1 plus b times y minus y1 plus c times z minus z1 equal to 0. And point Q is essentially just going to be our constants right here. So essentially our x1, our y1, and our z1. So for step 2, we're going to find the parallel vector of our two normal planes. Our two normal planes being right here in the left-hand corner, x plus y minus z, and 2x minus y plus 3z, or more specifically, our vector coordinates. And we're going to find the cross product of those two vectors. So we're going to have our IJK matrix right here to find our new parallel vector. So for our I matrix, we're going to have 3 times 1 minus negative 1 times negative 1, or in this case, it'll just be 1, so 3 minus 1. So we should come out with 2i. And then we're going to go straight to our J matrix, which is 3 times 1 subtracted by negative 2, or in this case, 3 plus 2. So we should come out with negative 5j. And for our K matrix, we'll have negative 1 times 1, which is negative 1, subtracted by 2 times 1, or in this case 2. So we should come out with negative 3k. And from our polar coordinates here, we should get our vector coordinates 2, negative 5, and negative 3. And this parallel vector of our two normal planes we'll just call vector W. So our third and final step is that we're going to find the normal vector for the plane that passes through the point that's given to us, in this case 1, negative 1, and 1. So we're going to take our point P, which was stated to us at the beginning, and point Q, which is the point of intersection that we found earlier, and we're going to create a new vector, vector PQ. So to find vector PQ, we're going to take each of the points, P and Q, and we're going to subtract the points for P from Q. So it's going to be, in this case, 1 minus 1, 1 plus 1, and 0 minus 1. And we should come out for vector PQ with the vector coordinates of 0, 2, and negative 1. And to find the normal vector of the plane that passes through our given point, we're going to take our new vector PQ and our previously found vector W, and we're going to find the cross product of those two vectors. So once again, we're going to go through our IJK matrix here, and we're going to first do vector W, so 2, negative 5, negative 3, Then we're going to do vector PQ, 0, 2, negative 1. And we'll have our individual smaller matrices here for I, j, and k. So negative 5 times negative 1, 6 minus negative 5 times negative 1 is 5 minus 2 times negative 3, which is negative 6, but because we're subtracting that, it'll come out to 11, so 11i. So negative 1 times 2 is negative 2 minus 0. So also remember that that j is subtracting, so it should come out to 2j. And for our k matrix, we have 2 times 2 is 4, so 4 minus 0 is, well, 4, so we'll have 4k, and our new vector coordinates will come out to be 11, 2, and 4, and this will be our coefficients for our equation of a plane, which is a, b, and c. So using what we just recently, using our newly acquired vector, we're going to then plug our values into the equation of a plane, and we should come out to 11 times x minus 1 plus 2 times y minus 1 plus 4 times z minus 0, which is equal to 0. And by doing some algebraic simplification, we should come out to 11x plus 2y plus 4z minus 13 equals 0. And that should be the equation of our plane.